like to re-record. Okay, so here's the distance formula. Exactly what we're solving for is the distance between 2 points. We're going to start on this page and then kind of work over this way. We're starting with the hardest skill, or the skill with the most steps. So, looking at this first coordinate plane right here, it does have point 1 and point 2. It might be kind of hard to see, but there's point 1 right here and point 2. And what we're actually solving for is the distance between those 2 points. And we're going to do that using this formula here. So, in order to use this formula, we need our x and y's, and that is the coordinates. So for point 1, just determining that coordinate, it's at 1, 5. Those in the back, can you see all right? Let's see how far I can zoom it in. Right, and then point 2 right here is at -5, -1. And we're going to use these points to plug into the equation. I'm going to write the points right here, 1, 5 and -5, -1. And then I'm going to label them. So with coordinates, you have your x and your y. So this would be x1, y1. And then your second set of coordinates would be x2, y2. If you're wondering which one is the first and which one is the second, it doesn't matter because distance is going to be the same whether you're going forward or backwards. Something to also note is distance can never be negative. If you're traveling a distance, it is a positive distance, unless you're time traveling, but we're not doing that. So distance is always positive. If you get a negative answer, you know you did something wrong. Okay, now that we have these labeled, we can plug it into the equation. So we have square root, and then just plug in your numbers. x2 is -5. That. So I just took these numbers, plugged it into the equation. And then you can solve. Use order of operations. So you're going to solve what's in the parentheses first. -5 minus -1 would be -6 squared. Got another -6 squared. -6 times -6 will be positive 36. And it solves down to square root of 72. Now looking at distance, and I'm using my phone. I have this calculator, but for whatever reason the settings aren't set to show you the actual decimal. So I'm using my phone as a calculator here. Okay, so if I were to take the square root of 72, I would get 8.49. So this equals 8.49. And then just make sure that's logical. Is this length about 8.49? Yes. Okay, now we're going to continue that for the next couple examples. So here in the second example, I have point 1 right here and point 2, and then I'm finding the distance between those 2 points. Point 1 right here is at 2, -2. And point 2 is at -5, 3. Then I will put these points over here so I can label them. 2, -2, and -5, 3. So we have x1, y1, x2, y2. You will be turning this in today, and I'm going to be looking to see that you have all the work that I put on my paper, so just make sure that you're following along, putting all the work down. Okay, once we have the coordinates, then we can plug them in. going to solve using order of operations. And 49 plus 25 comes out to 74, square root of 74. If you could simplify that easily, you would, but you can't. You could just plug it into the calculator and get 8.60 units. And that should be the distance of that line, which makes sense because it's about the same distance as this one from what we can visually see. I realize not everyone has like a calculator with them probably. So if you just solve it down to the square root, that is good for today. Okay, next example. Move this down. Okay, so start by identifying your points. Point 1 and point 2. Point 1 is at negative 3, 3. And point 2 is at negative 2, negative 4. Okay, so see if you can set it up and solve it at this point. Okay, so you should have gotten square root of 50. Did you guys get that? Some of you yes, some of you no. I said that you got it. Okay, so I'm working towards square root of 50. Let's see, so I'm going to do x2 minus x1, negative 2 minus negative 3, and then negative 4 minus 3. So here I have subtracting a negative, so you add the opposite. It just becomes 1 squared plus, we get negative 7 squared, so we get 1 plus 49, which becomes square root of 50. Good. If you didn't get square root of 50, do you know what you did wrong? It usually has to do with those negatives, I bet. Okay, the next one, try it. Okay. The next one, try it completely by yourself. Label the points, plug it in, and all that. Are you done? What'd you get? What'd you get? 2? Oh, what's that? Yeah. You got 2? I didn't get 2. What'd you get? Should have came out to square root of 37. I'm seeing a lot of that answers, so that's a good sign. So the coordinates you should have got, if you didn't get square root of 37, figure out what your error was. Maybe it was labeling the points, or just putting it in the equation, or subtracting negatives. Whatever that is, just figure out what it is. So the points you should have labeled are 3, -1, and -3, -2. From there, you should have plugged it in. We got -3 minus 3 squared plus -2 minus -1 squared. -3 minus 3 would be -6 squared. And then -2 minus -1, you add the opposite, so then that becomes -1 squared. You get 36 plus 1, so square root of 37 is our answer. Could plug that in a calculator, just make sure it's logical. It comes out to 6.08. You look at this and say, okay, that looks like it's about 6. If you got like 42, you'd be like, there's no way that's 42 units. Okay. Why is this not showing up on the camera? Okay. Anyways, okay. Now we're going to move over to the next page. Shakes. We're going to save these for last because that's the easiest of them. This one right here, we're doing the same thing we were just doing, but it's one less step. Instead of pulling the points off the graph, they already have the points there for us. All we have to do is label the points and plug them into the equation. So for number 5, this would be x1, y1, x2, y2. And then we can plug it into the equation. And number 6, same thing, x1, y1, x2, y2. And for number 6, you should have gotten 106, or square root of 116. Then we're going to skip 7 and 8 for now. I'm going to have you do that on your own in a second. But even if you've already started 7 and 8, just take a break, come up to number 1 through 6, and we'll look at those together. These are the easier of them all. We're actually going to, can I get everybody's eyes up here? I know you're probably just trying to work ahead, which I appreciate, but just for like 2 minutes up here. Okay, for these 6, we are going, the distance formula is a derivative of the Pythagorean theorem. So for these, we're just going to use Pythagorean theorem to solve them. I don't know if, I'm sure you remember Pythagorean theorem. We use Pythagorean theorem for right triangles. Remember, this is A, B, and the hypotenuse is C. And then you can use a squared plus b squared equals c squared to solve for the length of the hypotenuse. Do you remember that? Oh, it's not on the screen there. Do you remember Pythagorean theorem? If you skipped 8th grade math, you might not have worked with it as much. Some of you probably, most of you probably skipped 8th grade math. Have you seen Pythagorean theorem? Which grade was it?
I saw it in algebra.
Algebra 2? Okay. You didn't see it in algebra? Okay. Well, we work with it a little bit this year too, but I know there's like a whole thing on it in 8th grade math, which a lot of you probably skipped. So, okay. So we use Pythagorean theorem to solve for the lengths of a right triangle. And you might be thinking, well, that's a right triangle and this is a line. How is that even related? Well, if you have a line on a coordinate plane, you can actually draw a right triangle. So that's what we're going to do. Draw a right triangle here. And on this right triangle, you have A, B, and the hypotenuse is C. So for those who haven't seen Pythagorean theorem before, that's the idea. You have your 2 legs of the triangle, which are A and B, and then the hypotenuse, the longest side, is C. In order to solve for the longest side, we need the lengths of A and B, and since you drew them on a line, you can just count those units. So here we have 3 units, and then on the bottom, 1, 2, 3, 4, 5 units. When you're counting, remember you're counting the length of just the side. If you try to look at the triangle as a whole, it gets kind of confusing, but just count the length of that side there. And so now that we have A and B, we can solve for C. So we're using this equation, 3 squared plus 5 squared equals C squared. And now we're just going to solve. 3 squared is 9, 5 squared 25 equals c squared. 9 plus 25 would be 34. And then just take the square root of both sides, and the answer is square root of 34. Okay, we'll continue with that same process for number 2. Drawing the right triangle. We have 1 unit here, and then on the bottom 1, 2, 3, 4, 5, 6, 7, 8 units. And then just plugging it into the Pythagorean theorem. Okay, number 3, we just draw it like this. See if you can do 3 on your own. For those finishing up, if you got square root of 52, that means you did it right. didn't get square root of 52, let's look at it. 1, 2, 3, 4 units here. 6 units here. 16 plus 36 equals c squared. And then this is 52 equals c squared. Square root of both sides. So the answer is square root of 52. Okay. So what you're going to do is finish up these 3 problems as well as these 2 problems. If you need help, of course, let me know. Once you have completed it, all your work is shown, then you can turn it into the basket, and then you can, we have laptops now. I'll go over laptop procedures in a second. Okay. When you're done, then you can get a laptop to finish your Khan Academy. If all 10 Khan Academy assignments are done for the week, then you can ask to get your phone. So, okay, I'm gonna stop recording now. And bye, I'll see you later.